In our last episode, we put the Xyplex and Xylogic's terminal servers to the test, and while we ultimately prevailed in getting both units up and running with PPP, it was definitely frustrating at times. We also received voicemails on our Packard Bell Platinum from several viewers with their thoughts.
I very much enjoyed your terminal server showdown between Xyplex and Xylogic's terminal servers.
And amazingly, we even received our first fax message. But in this episode, the serial port will be moving on to part 2 of our terminal server shootout, and we will be evaluating the Livingston Portmaster 2E and the Cyclades TS2000. And we'll find out if we're able to take the huge step of opening up the ISP for a beta test. The massive city of Sao Paulo, Brazil was the unlikely starting place for a networking vendor in the late 80s. But that's where Daniel Dalla Rosa got his start with his friend John Lima. Their company was named after the French equivalent of the ARPANET known as Cyclades. And after spending a few years in a Sao Paulo garage, the duo relocated to Fremont, California, nestled at the end of San Francisco Bay. That's where they released their first product, a multi-port serial card dubbed Bcalm, in the early 90s. These were, quote, intelligent cards, which meant they didn't burden the host CPU as much as something like a simple or, quote, dumb card would. The Bcalm cards used the same CL-CD1400 UART that we saw in the Xyplex, so while their hardware design was nothing unique or special, Cyclades differentiated themselves by being one of the first hardware vendors to engage with the Linux open source community. At this time in the mid-90s, it was difficult or downright impossible to find certain hardware that was compatible with Linux. It was during this time that Phil Hughes, the co-creator of the Linux Journal magazine, had been looking for a multi-port serial card that worked with Linux, and only one vendor was willing to listen, and that vendor was Cyclades. Hughes sent out a request to a Linux mailing list looking for volunteers to take on a project to write a driver for the Bcalm Y. That's when Randy Benson stepped up to delve into the world of device drivers and Linux. Benson had experience writing drivers, so Cyclades agreed to send him a development board, the documentation for the Cirrus UART, and some tips on how to access the device. And after completing the project, it ended up being the first vendor-supported Linux device driver. And it was a great success for Cyclades. The Linux community ended up driving 50% of their serial card sales. More importantly though, this laid the groundwork to show other manufacturers that Linux support and open source development was a viable option. This early decision ended up changing the course for Cyclades. They continued developing new products and stayed close to the open source community. They eventually created the PathRAS remote access server in 1997. However, this was during a time when ISPs were abandoning terminal servers with serial ports. The advent of 56K dial-up technology brought about a new generation of high-density terminal servers for ISPs with digital modems. We'll be diving into the world of 56K technology and terminal servers in a later episode. The PathRAS evolved into the PR3000TS, which used their proprietary Cyros or Cyclades routing OS, and offered up to 64 RS-232 serial ports. However, given the rapid pace of evolution and development in network protocols, Cyclades wondered if the open source community could be the answer to keeping up. They ultimately opted to build their new terminal server, dubbed the TS2000, with Linux as the embedded operating system. The idea was that of flexibility and efficiency. They could spend less time maintaining the kernel and protocol stacks, and customers would have the ability to develop their own customized software. The TS2000 ran Monta Vista's Hard Hat Linux, a distribution specifically meant for embedded systems like these, and was the first Linux-based device of its kind. While primarily marketed as a console server for managing servers and data centers, the TS2000 still included features that an early analog modem ISP would want. And despite not being around in 1994 like our other terminal servers, we think it's a unique addition to the shootout, given its history. But let's see how this relative newcomer stacks up to the other terminal servers. The example the serial port has was kindly donated to us by one of our subscribers. The TS2000 has 32 serial ports, which is the most of any model in our shootout. And finally, an actual console port, which is a welcome sight. On the bottom, we see that our unit was built on March 6th in 2007, 12 years after the build date of the Zylogics. We've also got a helpful pinout diagram for the serial ports. So, let's try powering it on. On power up, we hear the fan and just get a single LED indication. Let's get the cover off. The consolidation of components compared to the earlier Zyplex and Zylogics units is expected on a much newer device like this. Over time, more and more functionality can be consolidated into single devices, making the board smaller and with fewer and smaller devices overall. At the center of the board is a Cypress, now part of Infineon, CPLD, or Complex Programmable Logic Device. We're not sure how this is implemented in Cyclades design, and it may just be for the LED array on the front panel, but let us know in the comments if you've got another idea. Towards the power supply, there is a Freescale PowerQuick microprocessor running at 50 MHz. These contain a PowerPC core based on the Motorola MPC 850, and it is the successor to the 68360 Quick, one of the most popular processors for embedded networking. It contains an onboard Ethernet MAC as well as other features that would have been separate devices on older terminal servers. The hard hat distribution of Linux that Cyclades used for the TS2000 had off-the-shelf support for these processors, making implementation that much easier. There are two Atmel flash devices here for a total of 4 MB of flash storage, and the TS2000 model has 64 MB of memory, which is not expandable. Cyclades actually had no idea how much flash storage and RAM would be needed during the initial design of the TS2000, but 64 MB would be more than enough for an ISP, even if all 32 serial ports were utilized. On the Ethernet side, there is a National Semiconductor PHY, and the only one in our lineup that supports 100 megabits per second. For the UARTs, Cyclades used the XR, now Max Linear, ST16C654, which supports data rates up to 1.5 megabits per second, far beyond what would be needed for a dial-up modem. And each UART supports 4 serial channels, so there are 8 XR devices to support all 32 serial ports. Finally, there are ON Semiconductor MC1488 and 1489 line drivers and receivers, alongside COM chip devices for electrostatic discharge protection. It is incredible to see the difference a full decade has made for terminal server hardware design, and we're hoping the software configuration has also followed the same trend. So let's try it out. We're connecting a Cisco-style console cable, our Ethernet connection, and powering it on. Our terminal is set for 9600 8N1, and after a long delay, we finally see a bootloader starting the Linux kernel. The boot process takes about a full minute, with the file system loading from flash. We see the Linux kernel version is 2.2.14, which was released in the year 2000. But this kernel has a compile date in 2006. Now at a login prompt, we first tried the root user with the default password of TS-Linux, and fortunately it worked, so we won't have to go through a password reset process. We're greeted with some instructions warning us to follow the Cyclades manual and to not configure this as a normal Linux system. We're now in what seems like a familiar Linux shell, with some commands you'd expect to see. But this is a stripped down embedded Linux distro, and the file system is a RAM disk. So that means any file edits will take place in RAM and not automatically persist after a reboot. And here's a list of files that get saved to flash memory storage. And the save conf command is what saves those files to flash. We can see here this unit is running version 3.0 of the Cyclades TS software. This matches the sticker we observed earlier. Presumably this is a more mature version after many 1.x software versions. So let's try to do some configuration. The manual referred us to the WIZ or WIZ command, which lets us set basic hostname and IP parameters. We're now asked if we want to save our updated configuration to Flash, and the save process ends up taking about 40 seconds. To configure serial ports, we can run config commands directly on the shell prompt. We played around with the Wiz tool a little bit more, but most of its functionality isn't directly useful for us right now. But we couldn't resist trying out the web interface, so let's log in as root and see what happens. It loads very quickly, and aside from there being a lot on the page, it has a refreshingly simple and clean user interface. But let's see if we can get a port ready to test with a modem. Looking at the config for serial port 1, there is a huge assortment of configuration options. We are trying out the dial-in profile wizard at the top of the page, and it adjusts many of these parameters for us. But the field named remote/local IP address is confusing. Does it mean remote or does it mean local? I guess we'll find out. We fill in an IP address that we want the dial-in user to get assigned. And once all of our changes are in place, we need to click Run Configuration on the left menu. Select the first option and then Activate Configuration. And if we get serious about using one of these units, saving and loading from an FTP server sounds pretty useful. The configuration process seemed almost too easy, but let's hook up a modem and try dialing in. Testing from our Windows XP machine, we're able to dial in successfully, and we are assigned the correct IP address via PPP. And pinging out to the internet works, so we can call this a success. And telnetting into the Cyclades, we can see the PPP process in Linux that is handling our connection. Working with the Cyclades is a night and day difference from the older terminal servers we dealt with in episode 4. But let's go over exactly what we liked. The fact that the Cyclades is based on Linux reduces the learning curve substantially for the command line interface. The TS2000 has a whopping 32 ports in a 1U form factor, along with the newest hardware in the shootout, making this a powerful terminal server right out of the box. And we can't forget that it has a real console port, making administration and troubleshooting that much easier. And while the web interface is no doubt fast and powerful, it isn't the most user-friendly, and you may still need to consult the manual depending on what you're trying to accomplish. Boot up and saving the configuration to flash tend to take a while, which can be an annoyance. And finally, the most important point is that this is a post-Y2K device and is not period correct for our ISP. Our goal from the outset was to create a pre-56K era ISP, something that would have been around in the early to mid-90s, so using the TS2000 would be like using a cheat code. But overall, we were definitely impressed with its capabilities and how it continued Cyclades' involvement with Linux. Let's move on to the final entry in our terminal server shootout. 5 years earlier, and just up the road from Cyclades in Pleasanton, California, Livingston Enterprises was founded in 1986 by father and son Ronald and Steve Willens. They initially started out developing information management systems for the technology and communications industries, but in 1989 they formed the Network Products Division, which ultimately led to the release of the revolutionary Portmaster communications server in 1990. It was an early example of a remote access server, and it was intended to provide serial and even parallel ports with TCP/IP network access. Livingston was involved early on with networking technologies like PVP, and their products were targeted specifically at the ISP market and sold through value-added resellers. In 1991, Steve Willens was credited with creating the Radius protocol, meant to provide a standardized way of authentication, authorization, and accounting, or AAA. Radius was integrated into the Portmaster products very early on, before it became an IETF standard, giving them a big advantage for organizations wanting to implement the new technology. We'll be delving in much deeper with Radius and its history in a later episode. Through the mid-90s, the Portmaster line grew to include multi-protocol routers, firewalls, and of course, a continued presence of terminal server models. Their products ran their own proprietary operating system coined COM OS and could be administered with a graphical user interface called PM Console, which was later rebranded PM Vision. Near their height in 1996, Livingston had a massive 67% market share among some 2,200 ISPs. They did this with a relatively small team of employees, no PR department, and not even any outside investment. The Portmaster was the terminal server for ISPs, whereas Xylogix found success with universities, and there were several other smaller players like Zyplex in the mix. The Portmaster was the gold standard at the time. David H. Dennis even called it the best terminal server by far in his ISP FAQ that's been helping us along since episode 1. And then in 1997, Lucent acquired Livingston, now at over 200 employees, in a deal for $650 million worth of stock. And after the release of the last Portmaster model, the Portmaster 4, Lucent discontinued the lineup for good. So given the popularity of the Portmaster with ISPs, we're excited to take a look at the example we have, the Portmaster 2E. We believe the 2E was originally released in 1992, and it features a modular design that can be expanded with more ports and upgraded to support newer technologies like ISDN. It's by far the physically largest terminal server in our lineup, and the only to feature actual DB25 ports, 20 of them in total, instead of the normal RJ45 ports that we've been seeing on the other terminal servers. And this is a clue to its intended purpose with modems. On power up, we're showing the rear of the unit as there is no LED indication on the front. And other than the fan, the only indication we have is a green power LED. Well, we've been waiting to see the inside of this for quite a while, so let's dive in. This is definitely a unique design in our lineup, and the build quality appears to be superb. We immediately see an AMD 386DX 40MHz CPU, which was actually the fastest 386 ever available. And that's alongside an ACC Microelectronics 2046 ST, which is a PCAT chipset that provides a memory controller as well as local bus controllers. Curiously, there is a 66.6 MHz oscillator here for both the CPU and the chipset, so the CPU is actually underclocked at 33 MHz. There are 4 populated memory SIMs and an EEPROM just beside them. The memory can be upgraded to 16 MB total using 4 MB SIMs. There are also 4 AMD AM28F010 flash memory ICs for a total of only 512 KB of flash storage. Our unit is fitted with an expansion card to provide an additional 10 serial ports. The serial ports use the Texas Instruments TL16C552 UART, which is PCAT compatible, and they support 2 serial channels each, so there are 5 on each card. And here we have AMD AM26LS29 line drivers and 26LS32 line receivers. The Ethernet interface board is located under the motherboard, connected via these pin headers here. And we're spoiled for choices here as the Portmaster provides us with an RJ45, AUI, and a coax connection. And our controller is the National Semiconductor AT/Lantic, which contains the MAC and supports 10 megabits per second Ethernet, and is obviously meant for PCAT buses. There's also a parallel port for connecting something like a printer to a network. Overall, the design is well executed, and we appreciate that expansion upgrades seem to be as easy as installing 4 screws and a couple of cables. But let's see what the software has to offer. We're connecting a DB25 serial cable with a null modem adapter to the S0 port, and our terminal is set to 9600 8N1. Wow, it boots up very fast. We're already at a login prompt in just under 30 seconds. We don't know the login info, and the troubleshooting guide says technical support needs to be contacted to override the password. Fortunately though, the code has been published that lets us do the challenge response method to gain entry. And now that we're in, we can reset the root password. With the help command, we see what looks like a very basic list of commands. This unit is running COM-OS version 3.5.1b17. And while the ifconfig command sounds like a typical Unix command, the options here are a little bit confusing. But following along from the hardware installation guide, we can use these set commands to configure our IP, netmask, gateway, and we can see a successful ping on our LAN. We're now following the configuration guide to set our system name, DNS settings, as well as to enable telnet access. And now we're specifying the beginning IP address for the IP pool that PPP users will get addresses from. We were confused by the broadcast address ending in .0 instead of .255, And the manual explains this is because the Portmaster defaults to a low broadcast address of all zeros instead of modern systems, which use a high broadcast of all ones. So we set broadcast to high, and now the broadcast address ending in .255 matches the other host on our network. We weren't immediately able to telnet in, and the manual does explain that a reboot is required after some configuration changes. And sure enough, after a reboot, we can telnet in. Now, let's configure the Portmaster for dial-in use. The manual has a chapter for this topic and an example of exactly what we're looking for. This part of the manual is written specifically for ISPs and provides a sample blueprint for how an ISP will lay out IP addresses on their network. So let's try just following the commands suggested here to configure all of the ports. And since we're not yet ready to use Radius, we're manually adding a user for testing. But after a quick test, dialing in with PPP was not successful. We think this may be due to some previous configuration when this unit was used as a console server, so we should probably do a config reset so that we're working from a clean slate. We connected back to the console on port S0 and followed the commands to reset the configuration to factory defaults. And after a quick reboot, we can log in with an empty password. So let's quickly reconfigure our unit, and we'll do so first from the console. And now that we can telnet in, we're going to configure port S1 for our modem test, and we'll use a speed of 57600 since we know this is correct for this modem, based on our previous experience with the other terminal servers. And again, we'll add a test user. And finally, we'll do a reboot for good luck. Connecting again from our Windows XP computer, this time we are seeing better results as we get registered on the network. We receive an IP address from the Portmaster's pool, and we're able to ping out to the internet. We wanted to find Portmaster-related software, including PM Vision, which was challenging as we couldn't find anything available online. Fortunately, we got in touch with Harold from the Osmocom project, which is an impressive collection of retro networking and telecom gear, and they're using a Portmaster 3 for their ISDN over Internet network. They shared an archive of Portmaster-related files, which we'll also be posting on the serialport.org website. The first thing we wanted to do is to try to upgrade our Portmaster to a newer COM OS. The release notes of COM OS indicate we can run tftp get COM OS, which sounds like a straightforward method. However, this didn't work for us as we kept getting the couldn't initialize file error even after trying a couple different COM OS versions. So this led us to trying out the other tools. We had success getting PM Vision running on Windows NT, and it made upgrading COM OS a breeze. With the upgrade done, we explored PM Vision further. This version is newer than the Portmaster 2. It refers to modems, which is probably for the Portmaster 3, which had digital modems integrated. We can use PM Vision to configure the ports on our Portmaster 2E, but the tool isn't all that helpful for doing this type of configuration, as it would simply be faster from the command line, as a setting can be changed for multiple ports from a single command. Let's take a look at monitoring the Portmaster though. There are color indicators for each port that will change depending on the status, and the session screen gives us detailed information on each port. And as we're dialing in, we can see the status changes to connecting. Once connected, we can see the blue indication for port 1, indicating a successful ongoing connection. So for us, the PM Vision software seems to have the most utility for monitoring and quickly checking the status of the terminal server, while the command line is definitely the way to go for configuration changes. Not limited to just its imposing physical size, the Portmaster stands out from the other terminal servers in a number of ways. It was the gold standard for ISPs in the mid-90s, and the manual is clearly written with ISPs in mind. The software feels dated, but overall easier to work with than the older Xyplex and Xylogix units, and we like how quickly the unit boots. The expansion capabilities and the ease of installing them are a nice touch as well. And finally, the icing on the cake is that port 0 does behave as a console port by default. And unlike the other units, the Portmaster 2E has DB25 ports, which could be a positive or negative depending on the application. On one hand, it makes the modem cabling very straightforward, but if you're connecting lots of modems, it would probably be easier to manage Cat5 cables between the terminal server and the modems. And the Portmaster is not perfect by any means. Configuration in the command line interface is not the most intuitive, as there is still a learning curve involved, and the PM Vision software doesn't help much there either. We also found that reboots are required in a few instances, which would be annoying in a live environment. But overall, working with the Portmaster alongside its manual really felt like we were recreating the 1990s ISP experience. And let's not forget that price played a big role. These were available new with 30 ports for around $3,000 or $100 per port. For an early ISP that just wanted a reliable terminal server as opposed to building their own with Linux and a multi-port serial card, the Portmaster 2 series was the ticket. It's hard to believe, but we're finally at the finish line. We've gone through all 4 terminal servers in the shootout, and amazingly, got dial-up and PPP working on all of them. Along the way, we've learned each of the terminal servers has its own unique history, design, and intended application, and it's difficult to really compare them fairly given all of the differences between them. But we really want to know what you think. We've posted a poll on our community page where you can vote for your favorite from the shootout. For us though, we'll be sticking with the Portmaster for now. It has the pedigree that will instill that much more nostalgia into our retro ISP. And speaking of which, now that we have our terminal server selected, we'll be opening up the ISP for our Patreon beta testers in the coming weeks. There's so much more we have left to do, and we'll be covering it all in future episodes of the ISP series, which we'll return to in the near future. But for now, we're going to enjoy our T1 fueled, Spark Classic hosted, Portmaster equipped ISP, and we'll be logging on to the information superhighway. See you in cyberspace.